Welcome to solverfy.
Okay, so this question wants us to show the following theorem. If f double prime of x is negative, so if f is concave down, then the integral is bounded between the trapezoid approximation and the midpoint approximation. So this can be pretty complicated looking to start. So I'm going to rewrite it in a different form. So if it's bounded by t of n below, that means t of n is less than f of x, but it also means that mn is bigger than x because it's bounded by that on the above. So we can prove this by showing that the trapezoid rule underestimates and at the same time the midpoint overestimates. Okay, so I think it's best to argue this graphically. So let's pick our favorite concave down curve. So in this case, just negative x squared of some variety. I'll just shift it over so we can see what's going on better. And let's pick a very large trapezoid so we really see what's going on here. So let's just pretend we have a trapezoid starting here and ending there. So our trapezoid starts here and ends here. And then we connect the two segments. So this is true for any trapezoid size we pick, but as you can see here, this is the area we estimate. I'll use a different color. So this is the area we estimate, but we're missing all of this black area. So if we consistently miss area under the curve, that means that the trapezoid underestimates. Okay, so now we're halfway done. We've shown that the trapezoid rule will underestimate the area of the curve. Now, let's tackle the midpoint approximation. Again, let's do the same curve, but this works with any concave down. So, let's say we have some rectangle, and we're taking the midpoint value right here and extending it from that x value to that x value. And this is pretty clear to see that we get all this, which is under the curve, but in addition, we also get this little portion outside. And if we add extra area with every rectangle, that means that we're going to overestimate the area. So, therefore, the midpoint overestimates. So, that's the proof. And just summarizing, we know that the trapezoid underestimates, so it's less than the integral from a to b of f of x dx. But we also know that the midpoint overestimates it. So this is exactly what we needed to show. We proved it.